All of you listen carefully. What is the question here? Define conduction band, valence band and forbidden energy gap. Okay. So these bands, valence band and conduction bands, are basically types of energy bands. So first you write what is valency band. In the valency band, definition first you remember. What is the definition? Now the energy band formed by a series of energy levels containing valence electrons is known as valence band. Known as valence band. Yes or no? Known as valence band. Clear? So this valence band is nothing but it is a consists of many energy levels. Okay, it consists of many energy levels like this. This energy levels contains valence electrons. So this band, total band, is called basically valency band. Yes or no? Clear idea? So little more points to learn about valency band. Now next point. Next point, right? This band is always fulfilled by electrons. Right, this band is always filled by electrons. Always filled by electrons. The next point, right? Always filled by electrons. This is the band of maximum energy. Right, again, this is the band of maximum energy. Maximum energy. Next, electrons are not capable of gaining energy from external electric field. Right, next, the electrons are not capable of gaining energy capable of gaining energy from external field. Gaining energy from external field. Write down here external field. So points to remember regarding valence band. First definition, remember, energy band formed by series of energy levels containing valence electrons is known as valence band. This band is always filled by electrons. This is the band of maximum energy. And the electrons are not capable of gaining energy from external field. No flow of current due to such electrons. Due to valence electron, there will be no current flow. Okay. So current flow is due to conduction electron only. So next point will write no flow of current due to such valence electrons. Complete this. Completed. Write down. Now next listen. Completed? Next listen. Next point. No flow of electric current. Electric current due to valence electrons. Due to valence electrons. Next, right? Next one point. last point to write for valence band. The highest energy level, right? The highest energy level, the highest energy level which can be occupied by an electron, which can be occupied by an electron in valence band at 0 Kelvin. In valence band at 0 Kelvin. Okay, OK means 0, that is not, don't read OK, that is basically 0 Kelvin. 0 Kelvin. 0 Kelvin is known as, or is called Fermi level. So here another level is coming, that is called Fermi level. So what is the Fermi level definition? It is a highest energy level in valence band at 0 Kelvin. Okay. So remember Fermi level definition. That's it. This is all about your valence band. So remember, valence band is, contains many energy level. That energy levels includes valence electrons. Okay, valence electrons. The next point, right? Conduction band. The next, right? Conduction band. So what is the conduction band definition, right? The higher energy level band, the higher energy level band, higher energy level band is called conduction band. Above valence band, it is conduction band. Next point, right? This band is partially filled by electrons. This band is partially filled by electrons. And if we will consider insulator and all, for insulator and all, conduction band will be empty. Okay. So we'll see the classification of conductor, insulator and semiconductor in terms of these all bands. So first you write, this band is partially filled by electrons. And this conduction band is also called empty band of minimum energy, right? Conduction band is also called as empty band of minimum energy. Empty band of minimum energy. So this is one point to remember about conduction band. Okay. We are telling empty band because no electrons present. Okay. For certain materials. But remember, for metals, what happens? Conduction band, valence band overlap each other. So at any temperature in conduction band, electrons are available. Okay. So remember here, conduction band is also called as empty band of minimum energy. Write down. Conduction band is also called as what? Empty band of minimum energy. Next one, write in conduction band, electrons gain energy. Just write in conduction band, electrons gain energy from external field, from external source or external electric field, from external electric field, external electric field. Next one, write the electrons in the conduction band are called free electrons. Next, write the electrons present in conduction band, the electrons are in conduction band are called as free electrons, and remember, due to these electrons current conduction takes place. So next one, write current conduction takes place, or flow of current, okay, or flow of current or current conduction takes place, right? Current flows due to free electrons, right? Current flows, electric current. Okay, you can tell basically current means different currents are there. So write here electric current. Electric current flows due to free electrons. Okay, due to free electrons. The electrons which are present in conduction. So this is all about conduction band and valence band. If anybody asks you difference also, you can write difference. Okay, difference also you can write. Now next point, we'll define forbidden energy gap. Forbidden energy gap. Yes. Next heading, write number 3, forbidden energy gap. Forbidden energy gap. What is forbidden energy gap? Symbol give like this, Eg. Okay, forbidden energy gap symbol give like this, Eg. What is this one? Now all of you listen. Already we defined the valence band. Valence band is basically different energy levels where valence electron are present. And conduction band also defined. Conduction band is what? Conduction band is the band where free electrons are present. Yes or no? So this is your CB, means conduction band. This is your VB. VB means valence band. Now the remaining this space, this gap, this is called Eg. This is your energy gap. Okay, this is called energy gap or forbidden energy gap. Eg basically. Okay, so CB means conduction band, VB means valence band. So what you write here? What is the forbidden energy gap definition? I can write. See, energy gap between conduction band and valence band is called forbidden energy gap. So write energy gap. The energy gap between conduction band and valency band, conduction band and valency band is called conduction band and valence band. Is called energy gap or forbidden energy gap. Remember this. And here no free electrons present in forbidden energy gap. So remember, in a forbidden energy gap, no electrons are allowed to stay. So there are no electrons. There are no electrons present. There are no electrons present in forbidden gap. Remember this. No electrons present in forbidden gap. There are no electrons present in forbidden gap. Are you clear about this energy gap? No doubt, everyone. Based on this energy gap, we can classify metals, insulator and semiconductor. For a insulator, higher energy gap will be there, Eg will be more. That means the distance or the gap between, the energy gap between Cb and Vb, okay, will be more for insulators. Okay, but for conductor what happens, that energy gap will be zero. Vb and Cb will be overlapped each other. Okay, so in energy band diagram we'll try to see that one. So forbidden energy gap is important. Remember the definition and some facts about forbidden energy gap. No electrons present in forbidden energy gap. Next point about width, you'll write width of forbidden energy gap depends upon the nature of substance. For conductor, gap is less or zero basically, and semiconductor comparable to some 1 electron volt or like that, less than 3 electron volt actually, and for insulator it will be more, okay, greater than 3 electron volt, like that one. It depends on the nature of substance. So right, the width of forbidden energy gap depends upon the nature of substance. Write down. Next point, did you complete? Completed all of you? Right hand. What are you telling? That one right now. I'll write. The width of forbidden energy gap depends upon the nature of the substance. About width. Another point about temperature. If temperature increases, forbidden energy gap decreases. Shall I go next? Write down. So the difference in energy, and here remember in this conduction band, this is your lowest level. This lowest level is called basically EC, conduction energy level, and here this is the highest energy level in valence band is called EV. So EC and EV, remember these two things. Here I am writing in yellow color, EC and EV. That EC and EV difference if we take now, you will get basically EG. That energy gap, whatever energy gap you are telling now, this one we can write also what? EC minus EV. Okay, EC is the highest energy level, right? More energy level, higher energy level as compared to EV. So EC minus EV is basically energy gap. You write and picture right now. EC minus EV equal to EG. this energy band called EC, and this one called EB. So EC minus EB is basically EC. So let's write about width. What is the width of the, how width of the forbidden energy gap depends. Okay, write down. Write down all of you. Next point. The width of forbidden energy gap. Forbidden energy gap depends upon the nature of the substance. The nature of substance. Next point, right? The forbidden energy gap. The energy gap decreases. The forbidden energy gap decreases with increase in temperature. Right on. The forbidden energy gap decreases with increase in temperature. It decreases slightly, very slightly decreases. Okay. So write down that. As temperature increases, energy gap, forbidden energy gap decreases very slightly. Remember that. And one point to write here. Star mark point give. So EG nothing but EG is basically EC minus EB. This one you came to know. And this one also you can write as H nu. This is energy gap actually. So H nu you can write, or you can write SC by lambda. If energy gap you know na, you can find about wavelength. And SC is nothing but already you know. SC what value substitute SC? Approximately 1240. Anybody remember? Electron volt nanometer. This is the unit SC. H is Planck's constant, C is speed of light. If energy gap between conduction band, valence band you know, then you can find what is the wavelength of the photons. Yes or no? If any photon is emitted or any transition happening, electron transition happening, then photon is emitted now. What is the energy? What is the wavelength of photon you can find? Okay, nu you know. Nu what is nu? Frequency of photon. Frequency of photon. Lambda is wavelength of photon. Wavelength of photon. So while doing optoelectronic devices, while studying optoelectronic devices, this formula will help you. You remember that. E is equal to SC by lambda or H nu. Planck's constant in speed of light multiplication is this much value. HC. This HC. These are H nu. EV is the highest energy level in valence band and EC is the lowest energy level in conduction band. EC and EV remember perfectly. So this is what they asked in that question. You define what is valence band, conduction band, and forbidden energy gap. So everything you remember. Okay. Suppose 2 mark question coming, this many asked, only one definition right. But all detailed explanation I have given here. Detailed explanation given so that any other question also you can solve with a energy gap. Yes or no? Clear? So valence band, conduction band, and energy gap you understood. Okay. I hope you got the point, girls. Okay. Thank you.